In this section, I want to go over certain problems that involve using the inverse functions, which we covered in Chapter 4, and simplifying them using the sum and difference formulas. But let's quickly review over some of the characteristics of these functions. You'll remember the inverse sine function, where we write it as sine to the negative 1, which means that the sine of y is equal to x. So x being a value that we got once we took the sine of it, when we take the anti-sine of it, or the arc sine of it, we get the angle. And so you can see when we take the sine of something, we're taking sine of an angle, and that gives us a result. But knowing x, the results of doing sine on something, we always get something at the very lowest, -1, at the highest, +1. And because we wanted this to be a function which passes the vertical line test, we had to limit our domain for y. Y will always be a something between -π/2 and π/2, meaning, that would be our range, not our domain. But basically, we left it into the first and the fourth quadrants, where sine is positive here and sine is negative here. So we report our result, the anti-sine, arc sine of x. If we have a positive x, then we're going to report it as being in the first quadrant. If we have a negative x, when we take the arc sine, we're going to report it as its location being in the fourth quadrant. For cosine, or the arc cosine, the inverse cosine, cosine is positive in the first, and then if it's a negative arc cosine value that we are taking, we are going to report it as being in the second quadrant. Cosine, remember, is x, so cosine is positive in this direction and negative in this direction. And so we limit it, we limit our range, our outcomes, the angle values we report as being in the first quadrant if the x value, the input value, is positive and it's in the second quadrant, and we report it as being somewhere between π/2 and pi if it is negative arc cosine that we are taking. And the tangent follows the same as the sine. So we do that also in the first and the fourth quadrant, and that becomes the range or the outcome of our radian or degree values for the arc tangent function. When we talk about the cotangent and the inverse cosecant and the inverse secant functions, you'll notice that they always follow the same as their counterparts, except for cotangent. Cotangent, so this is the one sort of exception. The cotangent actually follows the cosine function. So if it's negative, we report it in the second quadrant rather than the fourth, which is what we do for tangent. Otherwise, these follow the same as their cohorts, if you will, their inverse functions. Cosecant follows the sine, ending in the first or the fourth quadrant, and secant follows cosine, ending in the first or the second quadrant. Okay, so given that review of the information, just reminding us what our restrictions are here, as we approach these, we want to think of each of these inverse functions as representing different angles, okay? The results of them. So that may not always be the case. Sometimes they might turn out to be the same angle, but we don't know. So what we're going to do is just assume they're different, and if they work out to be the same, then they'll be the same. In this case, they're very similar, but notice that our tangent is negative, and tangent -3/4 puts it into the fourth quadrant, just like sine. And so whatever that, we're going to call this U angle. It's negative 3/4, which is opposite that angle and adjacent, opposite over adjacent. And so this is a 3, 4, 5 triangle, so I'm going to go ahead and just mark that last 5. Now it looks like cosine is also dealing with a 3, 4, 5 triangle as well, but because cosine's positive, even though cosine would be positive in the fourth quadrant, you can see 4/5, the restrictions for cosine put it, when it's positive, it has to be in the first quadrant. So this may be similar angles. In fact, they're giving us similar results there, but in reality, they are in different quadrants, so they are different angles. This is going to be V, and this is still 4. This would be 3, and this would be 5. The cosine is adjacent over hypotenuse, so we have that. Great. So we're going to think about those angles. Let's go ahead and use the sum formula for sine. And we know that the sum formula for sine is the sine of u, and we're doing this because we're ultimately taking the sine of these two angles that we may never know what they are. We don't necessarily need to know them. Because ultimately we just want to take the sine of their sum. So if we add these two angles together, what would be the sine of that result? So sine of u, cosine of v, and then with sine, our signs match up. This is an addition, so we would use plus here. And then we go cosine u, sine v. Now looking at our angles that we have here, we know that if we look at angle u, the sine of that would be negative 3/5. And that's going to be multiplied by the cosine of v, and the cosine of v we know is 4/5. And then we want to take the cosine of u, so that would be 4/5 as well, times the sine of v, which would be positive 3/5. So just to double check, cosine of u, yep, that's positive 4/5. Sine of v is going to be 3/5, and that's positive as well. All right, so we multiply these. Negative 3/5 is negative 12/25, and then we have positive 12/25, and when we add these together, that would give us 0. And so that is the result of the sine of the sum of these two angles, which are represented with their arctangent and arccosine. All right, again, now we're going to use the cosine formula for the sum of two angles. So we'll think of these as two different angles, u and v. So drawing them out so we can kind of see them. Let's see, the sine is negative, and so that again puts it into the fourth quadrant. And sine is opposite over hypotenuse, so that's a 3, and that's negative 3/5. And this is, again, going to be a 3, 4, 5 triangle. This isn't always going to be the case, but it just happens to be the case here. And then cosine is positive, and we know that cosine has to also be in the first quadrant. And so it is 3/5. It's actually a different angle. So it doesn't have that same 4 side because it says the cosine is 3. So this is going to be difficult. But I will wing it here. We know that this is 4 here. So if I have 3, then this is 4, and that is 5. So kind of have them similar triangles, but at different angles within those triangles. This is my V, and this is my U. All right, so then the arc cosine, well, actually, let's go ahead and just write out what the cosine is for these. With cosine, we have, we start off with cosine. We go cosine U, cosine V, and then we have the opposite. So since we have a addition here, we have a subtraction, and then we subtract the sine of U, sine of V. So looking at U, we see that the cosine of U, which is my bottom triangle there, is the adjacent over hypotenuse, so we have 4/5. We're going to multiply that by the cosine of V, which is the other triangle adjacent, so that would be 3/5. Oops. And then taking the sine of U, would be opposite over hypotenuse, so negative 3/5 multiplied by the sine of V, opposite over hypotenuse, 4/5 positive. Go ahead and multiplying these out, we get 12/25 here, subtracting negative 12/25. And subtracting a negative is going to make it plus positive. So in this case, our answer is 24/25. Almost looked like we were going to get 0 again, but nope, we didn't in this case. And for our last example, going through here, we're going to do a tangent, and it's the sum formula for tangent. Again, we're going to think of this as U and V. We have some different numbers here. A lot of the others seem to be similar, but our cosine is negative, and so as we think about the negative for cosine, we know that has to be in the second quadrant. And this would give me negative 4 adjacent over hypotenuse 5. This is a 3, 4, 5 triangle. 5, in a 3, 4, 5 triangle, or 5 has to be the hypotenuse. And one of the sides either has to be 3 or 4, and then you know the other side. And you could work that out using the Pythagorean theorem as well. The tangent is positive, so that tells me it's in the first quadrant, and it's 2 and 3, so that is opposite over adjacent. So this is my V, this is my U. And if we have 2 there, and 3 would be the adjacent. So that's 2 squared plus 3 squared equals C squared. 4 plus 9. So C is equal to the square root of 13, just skipping ahead a couple of steps there. Square root of 13 goes in there. All right, let's write out what the tangent sum of two functions is. I'll just say U plus V. And then we'll do our substitution. So with tangent, the signs on top match. So if I have an addition, I'm going to go tan U plus tan V. And on the bottom, it will be the opposite of whatever you have on top, 1 minus tan U tan V. And so we're going to do a bunch of tangents here, and with U and V. Starting with tan U, U is the one in the second quadrant. Tangent is going to be opposite over adjacent, so negative 3/4. Plus tangent of V, in the first quadrant, tangent is positive, and we get 2/3. And then on the bottom, we're going to go 1 minus tan U tan V. We already found those, so negative 3/4 times 2/3. So we don't even have to do a new calculation there. But we do have to add these together on top. So let's use 12. So I'm going to multiply the top and the bottom here by 4, top and the bottom here by 3. So that gives me negative 9/12 plus 8/12. which would give me negative 1/12. And once we multiply these, that gives me 1 minus negative 6/12. 1 we can express as 12 over 12. We like ones because we can just turn them into fractions really easy. This becomes a subtraction of a negative, so plus positive. So that gives me 18/12, which reduces down to 3/2, I think. 6 goes into 18 twice, and 6 goes into 12, 6 goes into 18 3 times, 6 goes into 12 twice. So we're going to divide this by 3/2. Of course, whenever we do a division of two fractions, we really just cheat a little bit and turn it into a multiplication and flip that second fraction, the fraction that's on the bottom. And 2 can go into 12 6 times. So this leaves me negative 1/6 times 1/3, or negative 1/18 as my final answer. It was kind of nice. We actually didn't have to use that square root of 13. I kind of just did that automatically. But with tangents, we only used the two legs of the triangles, so that made it a lot easier for us. So as you work through these, remember those restrictions and pay attention to the signs of the numbers that you're taking the arc cosine of, or arc tangent of, or arc sine of. Determine which quadrant it must be in based on the sign, and draw a quick little picture of those triangles, knowing for the sines and the cosines and the tangents that you eventually take of those angles, what quadrant they're in and what signs should be attached to them. Of course, a triangle really can't have a negative side, right? But we can write it like that just to remind ourselves that we are going to the left. So that is a distance of 4 to the left. It also reminds you of what the sine or the tangent sine should be when you are taking other iterations of that angle. And that will make sure that when you take the tangent of something that you only knew the cosine before, whether it should be positive or whether it should be negative. Good luck on the rest of 5.2, and then we'll head into 5.3.